Hello, everyone. Welcome to Theo-MathProblemSolver. And I'm excited, to take you through the concept of differentials. And I would want to mention that differential is a very powerful tool that we can use to find approximations of functions at a point. And then also we can also, you know, if time permit, we can also leverage the same concept to look into areas of linearization of functions at a point. So at this point, if you have not subscribed to my channel, please do so, and like, comment, and share the content to other colleagues and loved ones, and so that anytime I kind of upload my content, by you clicking on the notification button, you'll be the first to receive them. Thank you so much. So stay tuned. All right. So suppose I give you a function. I kind of give you a function. Let's call it f. So I would say that, so f for definition. So let's start with some few definitions. So this is a definition. Suppose that f is continuous and it is a it's a differentiable function, okay? And it is a differentiable function. Suppose that f is continuous and it's a differentiable function. And let's say there's a small change and a small change, which we denote it as this delta s, okay? So when you see delta s, I mean to say a small change, okay, or a change in x, okay? So when that happens, so suppose that y equal to, let's say, let me use a different pencil. Suppose that y is equal to f of x, okay? Then we claim that over here, I claim that, let me just give some space for us to what I'm doing. Then over here, I claim that f prime of x will be approximately changing y with respect to changing x, okay? Very good. So on that note, I can just make y to stand alone. So by making y to stand alone out of this, you're going to have what? Change in y to be equivalent to f prime of x multiplying x, right? Very good. And this stems from this, okay? By making y the subject from here, we are able to get this. Is that okay? Very good. And I would want to say that this definition is also important. So I want us to take our time to really understand it, and by applying it, invoking on this theorem, this particular definitions, we can use that to solve problems. So please take note of that. Very, very, very important. Now let's look at some one or two examples under this, and we see how best we can use that. Now, how do we approximate root of 27? How do we do that using such definition? The definition we just talked about. How do we do that? All right. So solution. Now, what we can do is that, how do we do this? Now we know the definition, right? Now, I would want us to, say that okay, so we don't know the function you're talking about, okay? So what we can do is, let's say f of x equal to root of x. So since this is kind of, we are looking at the radical root, okay? Okay, so square root of 27. So it means that the function is of this nature, which is root of x. Is that okay? So x is something we will talk about later on. So let f of x to be equal to root of x. Okay, and x, I should want to point out that x is equal to a number that's close to 27. Okay, and a number for which it is easy to compute, and a number for which the square root is easy to compute. Is that okay? So x, let me state it once again, that x is equal to a number close to 27, because under the radical, in the main problem, under the radical, we were having 27. So we're going to pick x to be a number that is very close to 27. And such number that you pick should be such that it is easy to compute, okay? I mean, the square root of that should be easy to compute without so much struggle. So you ask yourself that what number is close to 27, but when you take the square root, it's easy to get a result. And the easiest number that should come to mind will be 25. Good, right? Good. So on that note, if that's the case, it just means that you have to let x to be what, 25. Now, if x is 25, what then becomes the small change that has occurred? If x is 25, what then becomes the change in x or delta x? Or what number should we add to 25 so that we get 27? And that is what? 2. Good. Good students. Do you see that? Very, very, very important. And I want to point out that this particular example is also important. This particular example is also important. And all that we are doing today, this particular definition is also important. It's applied everywhere, everywhere, everywhere. Let me take my time to say that, because we are going to leverage this to solve a lot of problems. So please, I want us to keep ourselves, as fit as a fiddle, so that anytime we are being confronted with the issue, we don't get fumbled. We will just say, hey, come on, I can't use this definition, this theorem to solve them. Okay. All right. So let's get started. All right. So let's go. So if that's the case, we may want to find now per the given, by using this, it just means we need f prime of x, right? Now, what would be f prime of x? So this is the same as what? X to the power half, right? Good. Now, what becomes f prime of x? F prime of x will be what? So you drop the power, then you subtract 1 from the power, that gives us minus half. And this can be written as what? Right? We have that. Now, per the given what's the name? Definition, we have changing y to be equal to what? F prime of x multiplying change in x. Now, it just means that we have to evaluate, we just have to, evaluate that. Now, what is x? X was given as what? 25, right? And change in x was already we said it's 2. Now, what it means is that I need my f prime evaluated at 25 and f prime evaluated at 25. It just means that wherever I see x in f prime, it just replaces by 25. And when we do that, what do we get? We are going to get what? 0.2. Is that okay? So 0.2. Is that okay? Very good. Remember that this is just a change in y. This is just a change in y and not the whole function. Okay, this is just a change in y and not the whole function. So on that note, what you're going to do is that we are going to add this value to the main to the what? To the main function. Okay. So all right. So to f of x, is that okay? So it just means that my root of 27 will be equivalent to root of what? 25 added to my change in y. Please, is that okay? If you don't understand it, please let me know. So root of 25 is what? 5. And what is your change in y? Our change in y was 0.2. This is equal to what? 0.2. Now, if I were you, I would take my calculator and take the root of 27. What's the root of 27? Is what? Approximately point what? 5.2, right? Root of 27 is approximately 5.2. Yeah, so by using this differentials, we've been able to solve this particular problem without necessarily using the calculator, right? So it means that without using the calculator, we can just use differentials to solve that, which means that differentials are so much powerful. They are so powerful. Okay, so it comes with a magic. It's almost as if I don't have to use my brain so much. Supposing I'm in an exam room and I just want to solve a problem and I don't have a calculator. Okay, I can just use this differential and that'll be all. I don't have to waste my time on that. Is that okay? Is that okay? And over here, I want to stress that I think some of you may be wondering why we did that. Over here, remember that this particular problem, this what we just solved, we were just looking at it from just say that if I'm given a problem like root of 27 now, for us to, you know, find an approximate value, what we need to think about is to look at a number that is close to 27. Okay, let me say that again. A number that's close to 27, and the only number that is very close to 27 for which the square root is easy to compute is 25, right? So on that note, we have to use 25 as my x. Now, having gotten x to be 25, now the question I ask myself is that what number should I add 25 say that I'll get 27? And that's 2, which means that my change in x is 2. Is that right? Good. Now, per the definition, we all have to find the first derivative. And by finding the first derivative, we get 1 out of 2 root of x, right? But then we have to evaluate that at x. Now we know that x to be 25, so right? So we did do that and we kind of compute that and we had 0.2 as our change in y. Now having got this 0.2, that is not a solution to the problem. Now you have to, this is just a change in y, okay? So you have to add this particular value to the main thing that you want to solve, which is f of x. But remember that your x is 25. So root of 25 plus 0.2 would give us 0.2, which is approximately 0.2, okay? This is an approximate value 0.2. And when you also try with a calculator, root of 27 should be approximately 5.2. Is that okay? Very good. So at this point, if you have any questions, please let me know. Put in the comment section, like my content, comment, click on the notification button so that anytime I release new content, you'll be the first to receive. And also, if you have not subscribed, please do so. Share my content with your colleagues, with their loved ones. Let's help demystify the myth around mathematics, something that mathematics can never be learned. Mathematics is only for the geniuses. Mathematics is not creative, but look, math can be learned. Oh yes, with the right person to lead you, math will be the easiest one for you. So please and please again, stick to my content, love it, watch it in your sleep, just be thinking about it and you'll be fine, okay? Continue to spread my content to your loved ones and let's help demystify the myth around mathematics. All right, so let's move into the next problem. All right, so example 2. So this is our example 2. Now, example 2, we have this. Now, we want to approximate the root of 98 using this same definition, okay? So using this same definition, want to approximate root of 98. And we have been instructed to find to approximate this to 5 decimal places. How close is your approximation? How close is your approximation? How close is your approximation? So let's see how best we can solve this particular problem. Let's see whether we'll be able to get this approximation. They have used a calculator to get this value, but let's see whether we can get a value that is very close to that. Now, the first thing to do, we want to approximate the square root. Now, what we will say is that let what f of x to be equal to square root of x. Now, what to be our x value? Remember, x value, x should be a number that is close to 98. But then such a number should be such that the square root is easy to compute. So what number is close to 98? Such that its square root is easy to compute. Let's give it a try. All right, let's see on the, okay, let me see you guys saying something in the comment section. Let me see. That should be what? What number? Such that if I pick as my x, and at the same time, if I find the square root, it should be easy to compute. And the number is what? It's 100. It's 100. Look, all right. So let's get going. So the number is 100. So let x, let my x to be 100. Good. Then what to be the change in x? If x is 100, what to be the change in x? What number should I add to, should I add or subtract to x such that I'll get 98? Is what? It's -2, not 2. Someone said 2. No, it is going to be -2. We want to, this minus sec that we should pick -2. It should be minus sec that when we subtract from 100, we should be able to get 98, right? Very good. Now, the next thing to do is to find what? Is to find my f prime of x. So what would be my f prime of x? We've done that already, so we just go straight to the point, okay? Now, if that's the case, what then becomes, if that's the case, what then becomes my change in y? My change in y, according to my definition, is this. Now, I need to evaluate my derivative at x equal to 100, right? And my change in x is -2. And that is what? That should give us what? Negative what? 0.1. Is that okay? So now what we are going to do is that we are going to now approximate. So now, let me use a different pencil. Now approximate. So we are going to approximate the root of 98, okay? So by approximating that, so you have 98, which is equivalent to root of 100 plus change in y, okay? And the root of 100 is what? 10. And the root under the change in y was what? Was -0.1, which will give us what? Which is approximately 9.99, right? So did we meet the target? Remember that the problem they had 9.89949, and we had 9.9, which we are very close to what they were, which we have done a very great job. So yeah, it just means that the difference will just be what? The difference. So we are 0.001 within the actual value of root of 90, of which we are right? Good. So at this point, I believe we've been able to understand it better and all of that. At this point, I want us to, jump to a very important definition. And I believe that definition is something that for the rest of this particular episode, we'll be using to solve several other problems as well. Okay? It's called the differentials, but there's a way we want to kind of write it for notation's sake, okay? Now, suppose that my y equal to f of x, then we defined the x, the differential of x is, okay, let's take note of that. So which is the same as what we already know. So the change in x, now we say differential, okay? So my dx, we said that, let me use a different pencil rather instead of this. Now we said that the x is the differential of x. So when I say dx, I just means the differential of x, okay? and then dy as a differential of y, and we denote that as this. Okay, so if I have y, look over here, please let's pay attention over here. So if I have y as f of x, then my dy with respect to the dy with respect to the x will just be what, f prime of x, right? Then over here, I can decide to make the dy the subject. By making the dy the subject, I'm going to have dy equal to what? F prime of x multiplying what? Dx. And that's what we have over here. Okay? That's what we have over here. So please take note of that. Is that okay? If you have any problem or if you have any questions, please put it in the comment section. I'll attend to that. And at this point, you have not subscribed, please do so. Put on notifications, turn on the notification button anytime I release new content to be the first to have that. All right, take care. So let's go to the first problem of the day. So the first problem of this particular definition is just straightforward. So let's go straight to that. Now, how do we find dy? How do you find the change in y or the differential of y? How do you find the differential of y? So we have y being equal to x multiplying 4 minus x to the power y, to the power 3, sorry. How do you find the differential of y? So this is a product of two functions. So what do you do? Since this is a product of two functions, we can cover the x and then take the differential of the chain or the power function, then plus 4 minus x to the power 3, then find the differential of x, the derivative of x. Now, what is the derivative of this? So by using the chain rule, we can easily do that. Okay, by using the chain rule, we are going to have what? Then we find the derivative of x, and that is as 1. Okay, so in that note, you're going to have 4 minus x to the power 3. Then when you kind of simplify it a bit, you should have what? So this is your, by simplifying it a bit, you should have minus 4 minus x to the power 2, x minus 1. Okay. Now, since we just need the dy, we just make the dy the subject. And by doing so, we do our cross multiplication. And then we'll have this. Is that okay? So we have this the differential of y. Okay. So we have this as our differential of y. Now the B part says that, so with the B part, we're asked to find the differential of y when x is 5 and then the differential of x as 0.2. So when x is what? X was given us 5. So it just means that wherever I see x, I should replace it by 5. And then my differential of x as 0.2. And what do we get if you do that? If you use a calculator, you should get what? Negative 0.32. Is that okay? All right. So at this point, if you have not subscribed, please do so. Like my comment, like my content, comment, and then help spread it as well. Thank you. Now, at this point, I want us to look at linearization. The kind of problems that all right. So the kind of problems we are being confronted with in life are non-linear in nature, right? So life is not always smooth, right? It's not as rosy as someone may say it. All right. So it's not like that. So it just means that for us to sometimes level those, fluctuation in that, or some level of high peak and low peaks and all of that, the best we can do is to see, is to ask ourselves that, can we really use a tool to solve, or to level everything, or to calm every storm situation that you are being confronted with? In mathematics, we have a very interesting tool, a powerful tool that we can use to do that, especially when we want to solve a problem, and we see that the problem is becoming very cumbersome to handle. What we do is that we can linearize. And what do I mean by linearize? And as I mentioned, most problems that we are being confronted with in life are non-linear in nature, okay? So how do we linearize it? Linearize it means that we are making it smooth, or you're making it like a playing ground. You are leveling it so that you can easily work on it without you going up and down. Is that okay? Like a straight line. If I have a curve and I can bend it into a straight line, then I say that then in mathematics we claim that you have linearized it. Is that okay? You have we have linearized it. All right. So that is the same thing that we in mathematics we kind of do. Okay. Good. Now suppose that y equal to f of x being differentiable at the point A. Now the linearization of f at x equal to a is given as this. Okay, good. It's like you have a very mountainous problem, a very curvature problem, and you try your best to make it smooth. By smoothing, or by turning into a straight line, we are saying you are linearizing it at a point, okay? And by doing that, we said that it's going to y equal to f of f being evaluated at a plus f prime, the first derivative being evaluated at a, then multiplying x minus a. Okay. Then this is the equation of the tangent line. So this is the equation of the tangent line that is being evaluated at x equal to a. Okay, or at a point A. Is that okay? Good. So it's almost as if, so I can just try and give you a pictorial picture of what I'm trying to talk about. So it's almost as if you're in the XY plane. So let's call this X, and let's call this my Y. So if I have a curve as this, okay? If I have a curve as this, and so with this curve, this is what I want to do. So I want this curve to be as linear as this line. So let me use a different. So I want this curve to be linear as this. So just very good. So I want this curve to be linear, to be as linear as this line, okay? So for me to do that, it just means that I can just hold the endpoints of the curve and stretch it until such a time it lies on this straight line. Is that okay? Very good. Now, for me to do that now, it just means that I'm trying to evaluate, for me to do that, it just means that I'm trying to evaluate it at x equal to a over here, okay? Now, for me to do that, I need to assume that there's a value. So what it means that the distance for me to stretch the endpoint of the curve, it just means that the distance here has to be very, very, very small, right? And the distance also here has to be very, 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 very small. For me to hold the endpoint of the curve and stretch it on such a time it lies on this line, it just, means that the distance over there has to be very, very, very small, right? Has to be very, 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 very small. But then mind you that this line is tangential to the curve, okay? It's tangential to the curve at a it's tangential to the curve at a point what FA, okay? Do you all get it? Good. At a point FA. And that if it's tangential, it means it's a slope, right? It has a slope. And it having a slope means that we're going to have your F prime being also evaluated at A. Is that okay? Is that okay? Now, remember that we are trying to reduce the distance. So if you are reducing the distance, you know, if you're reducing the distance, then you have to, assume something, right? If you are reducing the distance, you just have to assume something. So suppose that the distance here was probably 4. Probably, let's say distance here is probably, let me say h equal to 4. Then as you are closing by, you realize distance will eventually approach 0, right? Probably becomes like 0.001 or 0.00002. As we are trying to close, then there's certain assumption that we have to assume. We want to assume that the error margin is very, 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 very small. Okay, because you may not really know whether you have really closed the gap. So we want to assume that the error that we can assume or we can make in the course of the approximation, the course of the closing the gap is very, 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 very small. Okay. So that's the simplest definition by which I can explain this. But however, if you need a detailed explanation as far as understand linearization is concerned, you can put your contact information in the comment section and I will attend to you. Okay, or just put in there, or if you can request my email as well, I can give it in the comment section. Then I would arrange with you to actually give you the further explanation on that. All right. So with that being said, let's move to the last example of the day. All right, let's get going. All right, now let's find the linearization of this particular function at a equal 27 and use it to approximate root of 28. Very, very important problem. Now, to construct the derivative, so let's start. So solution. So we are given f of x equal to the cube root of x, which is the same as this. X equal to 1/3. Now, to construct the linearization of f of x at x equal to 27, we need to find both f being evaluated at a and f prime of x being also evaluated at a. Our a in this case is 27, right? So we have to take note of that. Because remember, for the linearization, they said that linearization is what is this? Our linearization right? Was this. So if you want to linearize any function, this is the formula we use, right? So in which case we want to find the f of f or the function being evaluated at a and the f prime being also evaluated at a. So on that note, let's evaluate the given function at a. And our a in this question is what? Is 27. So 20 f of 27. Just wherever I see x, I should replace by 27. So I have the cube root of 27. And that should give us what? That should give us 3. Good, good. Now let's find our f prime of x. What is our f prime of x? So this is your f. Let's find it f prime. That becomes 1/3 x times what? Minus what? 2 on 3, right? This can also be written as what? 1 over 3 and then the cube root of what? X to the power 2, right? Very good. Now let's also evaluate such value at x equal 27. And that should give us what? We should give us 1 on 27. Yes. So we have this. Now what do we need to do to plug it into that? And that should give us the value. So this implies that our f of x can be approximated or can be, when we linearize that, we should get f of a. And now f of a, we had what? We had 3. And then f prime being evaluated at 27 was what? Was us 1 on 27 multiplying x minus a, which is what? Which is what? 27. So this is the an approximate, and I think this one we can still go further to simplify it. Let's simplify it a bit and see. So when we simplify this a bit, we should have what? 127 plus plus what? Plus 2. Now remember the question went further to ask us to approximate. So the question says that we should approximate root of the cube root of 28, right? So now to approximate the cube root of 28, we have to what? We substitute what? We substitute x equal to what? 28 into the linearization what equation, okay? Into the linearization equation. Is that okay? Very important. Now, on that note, we're going to have, so it means that wherever I see x in this, we just have to replace it by, we just have to replace it by 28, right? So on that note, we're going to have our f evaluated at that equal to what? Equal to 28 on 27 plus 2. And that should give us what? 82 on 27. So now, so this is approximately 3.0. If you use a calculator, you should get something as this. And this is repeating. But then when you use your calculator, you should have on your calculator, you should have what? The cube root of 28 to be what? To be approximately 3.0365 and some values added. All right, so this is how we can leverage our linearization to solve non-linear problems at some point, and we can also use the same to approximate some radicals as well. So please again, if you have not subscribed, please do so. Like my content, turn on the notification button, and then also I would say that share the content with other colleagues, loved ones. Let's help demystify the myth around mathematics. Stay blessed.